So today we are going to see the types of sets and few examples. Okay, so types of sets. So in maths, not all sets look the same. Some may have no elements and some may have just one, or some may have many. So based on this, we name them in different ways. So first one, we are going to see about the empty set. Empty set, it is otherwise known as null set. Okay, so if a set has no elements, or element kuda illa, then we call it as the empty set or the null set, or we call it as the void set. Okay, so it is written as this symbol or else this symbol. So this is the null symbol and this is the curly bracket with nothing inside. So this is the empty set. Okay, so let's see the example. If a is equal to x such that x is an odd integer and divisible by 2. So odd number divisible by 2 na eduvum irukadilla. Indha numberume odd number vandittu 2 ala divide agadu. So a is equal to null set. Understood? So it is not at all possible. So we said that a is equal to null set. So I am going to give another one example. Set of all integers between 1 and 2. Is there any integers or any numbers between 1 and 2? No, right? So the answer will be null set. Understood? So now, can you tell me, is 0 and null set same? So 0, it has one element inside, which is 0. So it is not empty. Whereas here, it has no element at all. So it is truly empty. Understood? Now we are going to see the singleton set. If a set has only one element, we call it as the singleton set. For example, a is equal to x such that x is greater than 3 and less than 5. X is an element of natural number. So greater than 3 is 4, less than 5 is 4. So only one value we get, that is 4. So 4 is the singleton set. Understood? Then I'm going to give you another one example, that is set of all even prime numbers. So what are the prime numbers? 2, 3, 5, 7, 11, 13, etc. Isn't it? So here even prime numbers is only 2. So 2 will be the singleton set. 2 is the singleton set. Understood? So next we are going to see about the finite set. Next is finite set. It means if a set has countable number of elements, then it is called as the finite set. For example, 1, 2, 3, 4. Okay, so we can count this, isn't it? So totally 4 elements is there. We can count it. So we call this as finite set. Another one example, vowel A, E, I, O, U. We can count. It has 5 letters in that. So that also will come under finite set. So empty set also has no elements, which is still countable. So empty set or null set, it is also a finite set because it still can be counted. So that we call this empty set as the finite set. Understood? So next we are going to see about infinite set. So finite set na count panna mudiyum. But if a set has ende illa, okay, for example, natural number, it begins with 1, 2, 3 and it goes on, right? So there is no end. So this one we call it as infinite set because there is no end at all. Okay, for example, 5, 10, 15, 20, etc. So this one, it goes on forever. So we call this as infinite set. All points in a line. So in this line, all points, there are numerous points and we cannot count it, isn't it? So this one is also infinite set. So is the set of natural number a finite set? As I already said, natural number is a infinite set. Next we are going to see about cardinal number of a set. So when a set is finite, we can count how many elements it has. So that count, it is called as the cardinal number. I repeat this, when a set, when it is finite, we can count how many elements are there. That count, it is called as the cardinal number. It is written as n of a. That is number of elements in set A. It means number of elements in set A. Understood? Now let's see example 1.3. A is equal to 1, 2, 3, 4, 5, 7, 9, 11. So how many elements are there? Just count it. 1, 2, 3, 4, 5, 6, 7, 8. So totally there are 8 elements. How many elements? 8 elements. So n of A, that is equal to 8. Understood? So what is n of A? That is number of elements in set A. If A is equal to 1, B, 4, 2, X, Y, Z, D, then can you tell me how many elements are there? N of A. Can you count the number of elements? So I am telling you the answer for this. 1 is 1 element. B is another 1 element. D is repeated, so you don't want to write it. 4, 2. It is a set, right? So we are counting it as 1. X, Y, Z. This is a set, right? So we are counting it as 1. D. We are counting it as 1. And set D. We are counting it as 1. So totally 1, 2, 3, 4, 5, 6. Totally n of A is equal to 6. Understood? N of A is equal to 6. Next we are going to see about the equivalent set. When two sets have the same number of elements, they are called as the equivalent set. So if we have in the set of A 5 elements and in set of B 5 elements, so we call this as equivalent set, like this. Set A, it is equivalent to set B. So in this equivalent set, we are not seeing the same elements. We are just counting the elements. Okay. For example, A is equal to ball, bat. B is equal to history, geography. Now we are going to count the number of elements. Ball, bat, 2 elements. And for B, history, geography, 2 elements. So n of A is equal to n of B, that is equal to 2. Therefore, A is equivalent to B. Next example, 1.4. So P is equal to X such that X is greater than or equal to -3, less than or equal to 0. X is an element of integers. Q is equal to the set of all prime factors of 210. Set of all prime factors of 210. So we have to check whether P and Q are equivalent or not. Okay. So let's find the answer for P first. P is equal to X such that X is greater than or equal to -3. So we have to start from -3, -2, -1, 0. Look at here, less than or equal to 0. So we have to stop till 0. So therefore n of P is equal to 1, 2, 3, 4. 4 elements. So 4. Okay. Now for Q, we have to find prime factors of 210. So 210, second table, then third table, 3s are 9, 5 3s are 15, then fifth table, 7 5s are 35, then seventh table. So that is equal to 2 into 3 into 5 into 7. So the elements are 2, 3, 5, 7. So n of Q, that is equal to 4 elements. So n of P, that is equal to n of Q, that is equal to 4. So n of P is equivalent to n of Q. So now we are going to see about equal set. So equivalent set and equal set, it is completely different. Okay. So two sets are said to be equal if they have exactly the same elements. Okay. So A layum irukra ella elementsum B layum irukanum and vice versa. Only then we say that A is equal to B. For example, A is equal to 1, 2, 3, 4. And B is equal to 4, 2, 3, 1. Look, all the elements are there in the set B. So we said that A is equal to B and this is the equal set. Understood? So if sets are equal, we write that A is equal to B. If the sets are not equal, we write A is not equal to B. Understood? Now look at another one example. A is equal to A, B, C and B is equal to A, B and C. So even though B has repeated letters in this, they are still the same elements, isn't it? So we are not going to write these repeated letters, only the unique letters. So A, B, C. So they are still the same, isn't it? So A, Set A is equal to set B. So next, are the sets null set, 0 and null set equal or equivalent? No, right, they are different. This is the empty set and this one, it has one element in it, that is 0, and this one also has one element in it, which is an empty set. These are different sets. Next, example 1.5, A is equal to X such that X is an element of natural number, X is greater than or equal to 4, less than or equal to 8, and B is equal to 4, 5, 6, 7, 8, equal sets. We have to check whether it is equal set or not. So let's find the value of A. A is equal to X such that X is an element of natural number. So natural number, it starts from 1. Okay. So they said that X is greater than or equal to 4. So we have to start from 4. 4, 5, 6, 7. We have to end it with 8 because it is less than or equal to 8. So we have to end it with 8. So the elements for set A is 4, 5, 6, 7, 8 and for set B is 4, 5, 6, 7, 8. So set A, that is equal to set B. So they are equal sets. Understood? So next we are going to see about universal set. So universal set means the set that contains all the elements related to the situation we are talking about. So this universal set, it is usually written as U. For example, if you are talking about natural numbers, then U is equal to X such that X is an element of natural number. And if you are talking about the planets, then U is equal to Earth, Mars, Jupiter, and so on. Okay, so based on the topic, universal set will change. So U means the biggest set we are considering. Next, we are going to see about subset. So let's say we have two elements A and B. Okay, so if every element of this A, it is also in the set B, then we say A is a subset of B, and it is written as A, it is the subset of B. For example, A is equal to 1 and B is equal to 1, 2 and 3. So 1, it is in both A and B, isn't it? So we said A is the subset of B. So I'm going to give you another one example. A is equal to 2, 4 and B is equal to 1, 2 and 3. Okay, so 2, it is in both the set. What about 4? 4, it is not, isn't it? 4 is not in B. So we will say A is not a subset of B. Next, thinking corner. Is W subset of N or Z? They say is whole number subset of natural number or integers. Okay, Z means integers, N means natural number, W means whole number. So natural number, it is a subset of whole number and whole number is a subset of integers. Because natural number, it starts from 1, 2, 3 and it goes on. So natural number, it is a subset of whole number which starts from 0, 1, 2, 3, it goes on. And whole number, it is a subset of integers. So integers, it starts from minus infinitive like minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, it goes on. So the answer is natural number is the subset of whole number is the subset of integers. So if A is the subset of B, every element of A must be in B. If even one element in A, it is not in B, A is not the subset of B. So if A is the subset of B, then N of A is less than or equal to N of B. That is, number of elements in set A is less than or equal to number of elements in set B. If A is the subset of B, then N of A is less than or equal to N of B. Understood? Now let's see the example 1.6. Insert the appropriate symbol, subset or not a subset, in each blank to make a true statement. Look at the first question, 10, 20, 30. 10, 20, 30, 40. So 10, it is there in both the set. 20 is there in both the set. 30 is there in both the set. So A is the subset of B. Now look at this. P, Q, R, W, X, Y, Z. P, it is not there in set B. Q, it is not there in set B. R is not there in set B. So A is not a subset of B. Next, activity 3. Discuss with your friends and give examples of subsets of sets from your daily life situation. So I'll give you a few examples. Uniform colors is a subset for dress items. Odd numbers is a subset for natural numbers. Like that. Let's see example 1.7. Write all the subset of the set A, that is equal to A, B. Okay, so there are totally 4 subsets, and the first one is the null set, that is the empty set. So every set, it always has an empty set as a subset. Okay, and the second one is A. You have to take only the first element. and the third one will be B. You have to take only the second element, and the fourth one you have to take both the elements. Okay, so A comma B. So the subset of A is null set A, B and A comma B. Understood? So this is example 1.7. So now let's see about proper subset. So what is a subset? If all elements of A are in B, we say A is a subset of B. That's the subset, isn't it? So what is proper subset? So if A is a subset of B, we will say A is a subset of B. And if A is not equal to B, we will say A, it is not equal to B. So then A is called the proper subset of B. Okay, and this proper subset, how we will write? A is the proper subset of B. Okay, so it is written like this. So now I'll give you a simple example. If A is equal to 1, 2 and 5 and B is equal to 1, 2, 3, 4, 5. So A is inside B, isn't it? But A, it is not equal to B. So A, it is inside B and A, it is not equal to B. So we call this as proper subset. Okay, so A, it is a proper subset of B. So now we are going to see about disjoint sets. So what are disjoint sets? So two sets A and B are disjoint if they have no common elements. If there is no common elements, we say that as the disjoint set. And we will say like A intersection B is equal to null set. So here intersection, it is empty. It means intersection is empty. So that's when A and B are called disjoint sets. So here I'm going to give you an example, that is example 1.8. So A is equal to 20, 22, 23, 24. B is equal to 25, 30, 40, 45. Okay, look at A and B. Is there any common elements? No, right? So A intersection B is equal to null set. So therefore A and B are called disjoint sets. Disjoint sets. And if two sets A and B are said to be overlapping if they have at least one common element. In other words, if A intersection B is not equal to null set, then A and B are said to be overlapping sets. Next we are going to see about power set. So what is a power set? The power set of a set A is the set of all possible subset of A, and this is written as P of A. That is all possible subset of A. That is the power set of A. Okay, so the power set of set A, it is the set of all possible subset of A, and this is written as P of A. So for example, if A is equal to 2, 3, then subset of A is equal to null set 2, 3 and 2, 3, isn't it? Power set P of A is equal to null set 2, 3 and 2, 3. Understood? And I'll give you under one example. If A is equal to null set and in the set we have null set, we have to find the power set of A. Okay, so let's find the subset of A. Is equal to, first we have to write null set, then we are going to take this set, that is we will write it as A. Okay, for example this one we will write it as B. So first let's take the first element, that is A, null set, then write it inside the curly bracket. Then we have to take the second element, then we have to write both the elements together, that is okay. So this is the subset of A. So what about power set of A? P of A is equal to, just write everything inside the curly bracket. It is easy, right? But it is a bit confusing, but it will be very easy when you do it by yourself. Okay, just the thing is you have to separate the elements. And if n of A is equal to m, then n of P of A, that is equal to 2 to the power m, that is 2m. Okay, so now we have to find the proper subset of a set A. Okay, so how to find the proper subset of a set A? We have a formula here. Okay, the number of proper subsets of set A, that is n of p of a minus 1. So that is 2m minus 1. So this is the formula. Just remember it. Now let's do example 1.9. Find the number of subsets and the number of proper subset of the set x is equal to a, b, c, x, y, z. So calculate the number of elements in the set, 6 element. So n of x, that is equal to 6. Okay. So number of subset, how can you calculate it? That is equal to 2m, isn't it? So number of subset is equal to 2m, that is equal to 2 to the power 6. That is equal to 2 into 2 into 2 into 2 into 2 into 2. So that is equal to 64. Okay. Next, number of proper subset, that is equal to 2m minus 1. That is equal to 64 minus 1. That is equal to 63.